Question 17 on the worksheet on forces on inclined planes. A block of mass 5 kg is placed on a plane inclined at 30 degrees to the horizontal. Okay, quickly after reading this, I'm going to resolve the weight. So there's going to be 50 mg cos 30 in this direction and mg sine 30 down the slope. Okay, and there's a normal contact force in this direction. Okay, the coefficient of friction between the block and the plane is mu. When a force of 40 Newton is applied to the block acting up the plane parallel to the line of greatest slope, the block begins to slide up the plane. Okay, so if it begins to slide up the plane, that definitely means that the friction is going to be in this direction, which would be mu r. Okay. Show that mu has to be less than this. Okay, so if the block is sliding up the plane and we need an inequality in this question, that means that this upward force has to be greater than this downward force. So that's how we're going to begin the inequality. 40 is greater than 50 sine 30 plus mu times r, and in place of r I'm writing this because r is equals to 50 cos 30. Okay, now you move it around. 40 minus 50 sine 30 is greater than mu times 50 cos 30, and then you divide 50 cos 30 here. Excuse me, which gives mu is less than under root 3 over 5. So we get the required inequality. Okay, part B. When a force of 40 Newton is applied horizontally, okay, so now this is a horizontal force, which is a problem because we need either a force perpendicular to the plane or parallel to the plane. So to fix that, we will need to resolve this 40 Newton into its a component that is parallel to the slope, this one, and a component that is perpendicular to the slope, this one. And since this arrow is in this direction, the arrow here will be downwards and the arrow here will be rightwards. Okay. And now we know that between the slope and the horizontal, there's a 30-degree angle. So similarly, between the slope and the horizontal, there's going to be a 30-degree angle. Oops. Okay, so this is 30. That would make the opposite side 40 sine 30. And this side 40 cos 30. Now look, this arrow is going upward. So what I'll do, I'll draw this force here, 40 sine 30, and clear this part. And the other force is downward, so I'm going to draw it here, 40 sine 30, and clear this. Okay, now let's also resolve the two weight components. So this one is always the cos component. So mg sine 30. Sorry, cos. This one is always the cos component of that. Cos 30. And this one down the slope is always mg sine 30. mg sine theta. Okay, this would be the normal contact force. Okay. Now, when a force of 40 Newton is applied horizontally in a vertical plane containing a line of greater slope, the block does not move. So again, it's at rest. Show that, correct to 3 decimal place, the least possible value of mu is 0.152. Okay. Now, the frictional force is it pointing upwards? Is it pointing downwards? The question is not telling you whether this system is about to move upwards or it is about to move downwards. Okay. What we'll need to do is we'll see which force is bigger. Is this force bigger? If this is bigger, then friction should be acting downwards. And similarly, if Okay. And similarly, if this force is bigger, then friction must be pointing in this direction. Let's see which is the case. Okay. So what is 50 sine 30? This would be 25, I believe. 50 sine 30 is, yes, 25. And what about 40 times sine 30? That is 20. Okay, so that means that friction needs to be backwards. Friction should ideally be in this direction. Okay, now let's find the value of mu. I just noticed a big blunder. This was the cos component of the force. So this was cos. Both of them can't be the sine component. Look, these can't be both sine. So I blundered. This was supposed to be cos 30. Let's just redo this. This is cos 30. Okay. So that would be 40 times cos 30 would be 36.64. Okay. This is 34.64. Okay. Which means that friction should be in this direction if the object is at rest, because 25 is less than 34.64, so friction is definitely in this direction, so that these two forces together balance out this force and the object stays at rest. Okay, now we'll do 50 sine 30 plus mu times r is equals to 40 cos 30. Let's find the value of r. R is balanced by two forces. So R is equals to 40 sine 30 plus 50 cos 30. Let me use this value here. So 50, in fact, let me just move uh, 50 sine 30 to the other side. So 40 cos 30 minus 50 sine 30 is equals to mu times R is the sum of 40 sine 30 and 50 cos 30. Okay. Now you divide this here. 40 sine 30 plus 50 cos 30. Okay. So this gives 0.152, which is the correct answer.